Good day everyone, we are Group Cybergenesis, and today we will present Arduino Project 11 Interact with Servo. Our group members are Nanjoy Nashtiglao, our leader, myself, Marcia Marpontillo, and John Michael Pojeda. This project is presented to our professor, Dr. Earl Marquez Albina, for our subject, Application Development and Emerging Technologies. In the previous project, we learned how to turn the servo to a specific angle using external signals. In Arduino Project 11, we take it one step further by using a potentiometer to control the servo motor's position. By rotating the potentiometer, we can change the angle of the servo in real time. This project introduces interactivity, where the servo's position depends on the input we provide through the potentiometer. You can also experiment with the circuit, for example, replacing the potentiometer with the tilt switch as the input, or swapping the servo motor with an LED as the output. This activity encourages creativity and tinkering to build new interactive projects. The material we use in this project are: first, Arduino Uno board, the main controller; second, breadboard to assemble the circuit; third, jumper wires to connect the components; fourth, servo motor, the actuator that we control; fifth, lastly, potentiometer, the input device used to adjust the servo's angle. With this project, we successfully demonstrated how to interact with the servo motor using a potentiometer, creating a fully adjustable and interactive circuit.
Good day. So here's the source code of our activity 11. Here you go. As you can see, activity 11 is essentially the same, or rather similar to activity number 10, but this time, instead of turning the servo automatically, we're gonna turn it manually using a potentiometer. So here in our header, we have the same header as an activity 10. We have the library. We're going to include it in our source code, and then we're going to create a servo object variable. Then we're going to have a initializing a value for the servo angle so that we can write it later on. Now we have another variable here called knob pin, which is essentially the pin for the potentiometer, and this pin will be connected to analog pin 0. Then we have the setup. It's really similar to activity number 10. We're going to attach the servo object that we've created here, and then we have the loop. The loop is really different from the activity 10, which is essentially the only thing that's different here from activity 10 to activity 11, because here on activity 11, we are going to control the servo part with our potentiometer. Now, let's look here. So here, we already explained it that the header is essentially similar to activity 10, and then we have added a additional variable called knob pin, which is going to be set up to analog pin 0. Now, to read the value from the analog pin, we're going to use the analog read that we've explained in the past activity and save it to the variable val. We then use the function map to scale the digital value of val to the corresponding angle value that we want for our servo. So what is this new function called map? Essentially, it is just a way to scale the detected value from this parameter, and then we have two uh, parameters here after this parameter. So we have the lower bound of the current value, which is 0, and then we have the highest value, highest upper bound value, which is 1023. We have the target value that we are going to use for our variable val. So we have the 0 for the lower bound and 180 for the upper bound, because we are going to use degrees to change the angle of our servo part. And then this value will be written with servo part right with the variable val. We have a delay of 15 milliseconds so that we have a nice and smooth way of turning the servo part using our potentiometer. Okay, so as you can see, if we turn on the potentiometer on the clockwise direction, or rather counterclockwise direction, the servo also turns counterclockwise. Now, if we turn it into clockwise direction, it also turns into clockwise direction. So, whichever direction you turn the potentiometer, the servo part will also turn as well.